Welcome everyone to the May version of the GoldSim Monthly Webinar. My name is Nick Martin and I work with GoldSim Technology Group. And today's webinar topic will be events and hybrid simulation. If you have any questions during the webinar, feel free to use your raise your hand button on the little console interface, and I'll either address the questions right away or at the end of the webinar. Let's go ahead and get started. So for today's webinar, we're just going to go over using events in GoldSim, and specifically how to use events in GoldSim to make a hybrid simulation. So we'll talk a little bit about events in general, and then we'll talk about the GoldSim event elements, and briefly touch on some simulation types just to sort of set the basis of the background for how you'd want to use event elements in GoldSim and how events can help your GoldSim modeling. And finally, we'll wrap up talking a little bit about hybrid simulation in GoldSim. So events, in sort of the simplest sense, an event is something important or notable that happens. Usually it involves a change in state. There's a particular condition that someone or something is in at a specific time, and the event then is sort of the change in that state to a different state. So we often have a pre-event state, an event state, and a post-event state. The event and maybe the post-event state, of course, should be different from the pre-event state so that there's been a change or that something's happened. And sometimes, to make things easier on us when we're analyzing events, we choose to categorize things to sort of make an event category. Like an example of this would be the annual maximum 24-hour precipitation depth. And that would just be a category because it's the depth over 24 hours, not necessarily the depth from 24 hours of continuous rain. So events crop up in many different fields, and what sort of composes an event really depends on sort of the perspective of the user. And you can see this is just an excerpt from Wikipedia showing what constitutes an event in a variety of different fields. And as you can see, there's sort of a wide spread of different things. So let's just sort of continue on the event background here and get through some of this stuff fairly quickly. But so what do events look like? And so we just have a series of plots here just showing sort of examples of an actual event. And we have the step function, and an impulse or delta function, and also a rectangular or boxcar function. So we just sort of step through what events could possibly look like. And usually there's just sort of an instantaneous occurrence, or maybe two occurrences where we're changing state in some manner. And events don't necessarily have to be, they could be a category. They don't necessarily have to be a continuous value. It could be a cloudy day rather than having, 15 millimeters of rain or something like that. So an event just denotes something happening or a change occurring. So let's move on and talk about events in GoldSim and sort of build into looking at the GoldSim event elements. In GoldSim, an event is an instantaneous occurrence that triggers a particular action. So we have kind of a two-part process. We have the trigger, and then what happens in the model as a result of tripping the trigger. And in GoldSim, there are several different sources of events. One source would be model events, and these are things that the model recognizes. GoldSim itself sort of internally recognizes that need to happen, and so it will take care of, making an event. And the most common sort of time when this happens would be when a reservoir hits a bound. So if you set an upper or lower bound on a reservoir, when that's reached, the model or GoldSim will insert an event to just find the point in time exactly when the bound is reached. And then of course you can also define events, and these could be timed or rule-based. So let's look a little bit here more at or talk briefly about, so an important thing to keep in mind with events is that some actually interrupt the simulation clock, and by that we mean it kind of inserts a model time step, and we'll see a little bit more about that as we look at GoldSim here in a minute. But the types of events that interrupt the simulation clock include model events, and that again is things that GoldSim does, and then timed events, and a couple special types of event triggers will also interrupt the clock. So let's look at the event elements in GoldSim. And so what we're going to do now is look briefly at 3 example models from GoldSim. The example models, as you probably all know, are installed on your computer when you install GoldSim, and you can see an example of the directory where these examples are installed there on the screen. So the first one I want to look at is called triggers. And just to sort of reinforce the example model idea, you can get to these by going open example, and then these all happen to be under general examples, and there's an events category. So the next 3 models we'll see all come out of there. Okay, so looking at this model, we have several different events here. And so the event elements, of course, if you go insert element and then there's an events category, and that shows you all the sort of elements that fall under event elements. This first one is a timed event. And so you can see here that the event is defined in terms of its occurrence type and occurrence rate. So we're basically saying this is a regular time interval, and it occurs every 3 days, I believe, once in 3 days. Our other options for occurrence type are random time intervals, and we'll look at these various options here in a minute as we go through additional models. So that's sort of the timed event in GoldSim. There's also a triggered event, and so a trigger event has, for event generation, rather than necessarily setting a regular time interval or some sort of time interval, we have a trigger dialog. And the trigger dialog is shown here, and you can see we have all these types of triggers, and this model that we're looking at right now just basically shows an example of each type of trigger. There is a more option down here that lets you sort of constrain or expand upon the logic in your trigger. Okay? So you can see the purpose of this model is just to show the different sort of trigger options. We have this first one, so it occurs, this triggered event occurs when the timed event happens, and that's the trigger. We can also say, oh, when something changes, let that trigger an event. And then, of course, if something is true or false, especially changing to one or the other would trigger an event, could be used to trigger an event. And then we have an at stock test. And so this is the first sort of trigger mechanism that inserts an unscheduled time step. And at stock test is just saying, oh, at a stock, a reservoir, or an integrator, when it gets to a certain value, or when it hits a certain value in the reservoir, then trigger the event. At date and at e-time, or elapsed time, those are pretty self-explanatory, but those are 2 other sort of triggering mechanisms that will also insert a model event. And the final mechanism is the auto trigger. So that's just a brief overview of different sorts of event triggers and a look at the 2 sort of standard event types, and that was the timed event and the triggered event. So we'll look at this a little bit more, but one thing I want to bring up right here is we're going to look at the simulation settings in this example model. So it's an elapsed time model. It's very simple, duration of 10 days, user specified, basic time step of 0.1 day. So this is a dynamic simulation. It'll march through time. And basically every 0.1 day there'll be a time step, and you can see all those scheduled updates by clicking on the Scheduled Update button. Okay? So we're going to run this model right now real quickly. And use this model as a way to look at the output we can expect given events and the settings we set in our model properties. So if we look at this table, and this is just from the at stock test, you can see we're seeing, we're seeing the results from every defined time step. There you go. Okay? Makes a nice chart. But we know that this trigger is set to happen at a time in between time steps. So one thing that's sometimes kind of tricky with GoldSim events, especially ones inserted by GoldSim itself, is how do I see these events and when these events happen, the ones that happen outside of the sort of standard time step. And so the answer to that is we go to Simulation Settings, and there's a little Advanced button down in the lower right. So if we go into that Advanced button, we can turn on this option to include unscheduled updates. And so now we'll run the model again. And we'll look at the same result element. The plot still looks the same, but when we go to the table's fairly different. Well, slightly different, I should say. And here, now you can see we see the inserted events that happen when we're not on the regular time step. And so you only see those in your results if you turn on that advanced option. The other thing that turning on that advanced option does is, let me find one here that doesn't change as much, is it only shows the values or the time steps, including the inserted ones, when there's a change in the value of the elements being plotted. Okay, so that provides you just a brief look at this event model. Let's look at another event model to sort of round out our discussion of events. And so this is another example model, and it's called the Timed and Triggered Events model. It's located in the same place. This is the same one we were just looking at. I'm sorry. Oh, no, this isn't. This is a different one. Okay, so this is just showing a similar thing to the model we just looked at, but it's focusing more on the timed events, and so it's basically showing examples of each of these occurrence types. And that's for the timed event, and so you can see you can do it on a random timer. You can use a stochastic to set a random time. You can also have it be triggered off a cumulative count and off of the remaining time. Okay? So that just kind of rounds out what we were looking at in terms of, how do you trigger these standard events? This model was showing with the timed events the different timing options. So there's one more example model that I want to look at here from just the sort of standard event examples, and that's the discrete events. And so this model is located in the same place as the other two. And so what this is showing is some of the more advanced event elements, and here we have a status, and this just sets, basically there's two trigger dialogues, one to set to true and one to set to false, and that trigger dialog is fairly ubiquitous in that it's the same, the same dialog, same options everywhere it appears in GoldSim. Okay. The other thing I want to mention about this model is this little grouping of three elements at the bottom. And so we have a timed event going to a discrete change element, going to a stock element. In this case, it happens to be a reservoir element. So we have this timed event that's occurring at regular time intervals. Every time that happens, it's triggering this discrete change, which is going to add 5 to the value of this reservoir. could also do this. The other type of element, stock element, that would accept these discrete changes is the integrator element. And that, of course, is located right beside the reservoir element in the insert dialog. And you can see here, and you would just put, link to your discrete change here. The one thing to be aware of with the integrator versus the reservoir is the reservoir will take the add instruction, but there are also two other instructions in there, and that would be replace and push. And so those two instructions are designed for linkage to the integrator element. So what this sort of three-element pairing we have down here at the bottom allows is for you to kind of set your own timing for the events and sort of isolate yourself from simulation time. So in one of the previous models we looked at, we have our duration and our basic steps, and we can see when these are all going to be. If we want something to happen outside of that sort of timing of every half day, we can use this setup and set, the timing for these elements on when this value will change. Okay? And we're going to talk about that a little bit more as we look at some of the more advanced models as we move through the webinar. So returning to the slide deck, I want to talk a little bit now about simulation types. And so this is just to kind of contrast, the methods of simulations where maybe you'd use events in different ways you'd use events. So the first one we're going to talk about is dynamic simulation. And we often talk about dynamic simulation in GoldSim, where we're talking about dynamic simulation involving a dynamic system. The system is changing over time. The system evolves in response to external and internal influences for the model over time. And typically we would contrast a dynamic system to a static system, and a static system would then be just a system that's static over time, or not changing very much over time. For this webinar in relation to events, we're going to focus more on using dynamic simulation to mean just a model that's evolving over time but at regular time steps. So in other words, we're marching through time, but we're not really, we don't have any events. It's just everything is a regular time step or a basic time step as we move through time. Okay? So with a dynamic simulation, you often have kind of two solution types, and that would be either analytical or numerical. And so the analytical solutions, as you probably all know, is just the closed form sort of mathematical equation solutions. And so we know with an analytical solution, we know kind of always how, or we can always calculate a solution. And maybe an easier way to show this is just to show this little line plot that's coming up. It should now be up for everyone. And so the line plot on the right there, you can see that sort of smooth blue line is a simple example of an analytical solution where we kind of know the answer at every point in time, right? So it's continuous and we know it everywhere, okay? And that would be the blue line. So it would be nice if we had analytical solutions for all of our problems. Unfortunately, that's kind of maybe not usually the case, and it's much more often that we have to make an approximation. One way of dealing or addressing needing to make an approximation would be to use a numerical solution. And so that's usually just a piecewise approximation. And so the red line at the right side of the slide shown on the screen gives an example, a simple example of a numerical solution. So there we're saying we have defined time points where we calculate the solution, and those are represented by those circles on the red line. And in between, we assume how it's going to behave. In the example shown, we assume it's going to behave linearly. And so we just piecewise assume a linear behavior between each of those defined time points. And so numerical analysis provides an approximation, but usually that's a good approximation and it's beneficial to our purposes. So we talked about sort of dynamic simulation where we're just sort of marching through time, and we're just saying with like a numerical solution we calculate the solution at our defined time points as we march. Then we contrasted that to an analytical solution where we would calculate or know the solution at every point in time. So there's one other another simulation type that would be good to talk about now, and this is kind of the exact opposite of what we were calling dynamic simulation. This is discrete event simulation. And so what we're talking about here is we're not really being continuous in time at all. We're just sort of only responding to events. And so a discrete event simulation models the operation of a system as a discrete sequence of events in time, where each event occurs at a particular instance and causes a change in state in the system. No change in state or no change in the system is assumed to occur between the events. So the only thing we're really interested in are these events. And so in that way, the simulation can be thought of as just sort of a conveyor belt of events. We just go along the belt, and only when there's an event do we do anything or does anything happen. And so just to give an example of this type of model to contrast to some of the other models we've seen so far, we're going to look at this risk assessment model, which is a probabilistic model. And there's really only one thing we want to focus on with this model. And that is the basically the simulation time settings. So as those come up here for you, you can see that we have our duration and our basic time step length are exactly the same. So we just have two scheduled updates, one at time 0 and one at time 30. And we're doing that because this model is all based on events. And so we're really just worried about these timed and triggered events and if that failure happens. And so we don't really need to march through time in the model, we just need to see if an event happens. And so that way we can get away with just having, one time step. And so we'd want to do that in this particular case just because we want to run a whole bunch of realizations because we're just really looking at sort of, rare failure rates. Okay, to move on now, we're going to talk about our third simulation type, and this is kind of where we've been setting the stage for to get to through the whole webinar. And so we're going to talk about hybrid simulation. GoldSim is a hybrid simulator in the sense that it can represent both continuous processes and discrete events in the same simulation. And we've seen examples of both. We've seen GoldSim working on dynamic models and just marching through time. And we've also seen GoldSim just dealing with discrete events. Okay? So there's no reason you can't combine those two things into a single model to make a hybrid simulation. And that's generally, one of the advantages or one of the strong points of using GoldSim. So let's look at another model, and this model is going to combine both discrete events and marching through time. And this model employs the Muskingum routing method, and so we're not going to talk too much about that method, but there's sort of one unique thing about this method that's kind of driven the particular representation in this model, and that is this method has a routing step which is derived from the underlying data collection period. And so you can't change it. You don't want any inserted time steps to change the calculation except on the routing step changes. So you can see in this model what we have is we're controlling when our sort of routing step changes and the values that it affects by using sort of the same three elements we talked about earlier, and that would be a timer, or an timed event, to a discrete change, to a stock. And so what this setup does is it makes it so that no matter what happens in the model, the value in info vector only changes when we want to. So it's not updated if the model inserts a time step because this reservoir reaches a boundary. This value won't be updated then. It'll maintain its same value. It's only updated by this discrete change, which is driven by the timer. So this is a way to enforce a fixed time step in your model, even though GoldSim will, insert events, insert time steps as needed to meet the needs, of all the elements in the model. So this particular approach shown here would provide a way to get around that, for specific elements to say that, oh, these only operate on this time step. Okay? So that's kind of a complicated method, and I don't really want to delve into the mechanics of the method or what's going on there, but more just to show, we have the timer to the discrete change to the stock, which is, letting us honor our routing step, or a fixed time step that's independent of what the model's doing with time in terms of inserting time steps. Okay? So, with hybrid simulation, we're going to have both events as well as marching through time. And so the one thing, with sort of marching through time that's kind of the same is we're using sort of a numerical approximation or a numerical solution. We're saying it's, we're assuming some relationship over our time step that holds across just that time step, so that in a way, kind of each time step is very similar to a discrete event, and that's just what the figure is showing here. Okay? Where they're different, or where you would want to think of them as different, even though sort of that, numerical solution approach, even with a dynamic model, kind of, each time step, each basic step might look kind of like an event. When we're actually, wanting to represent an event, you want to think about an event as being rarer or occurring less frequently than a model time step. And so events should be countable and occur less frequently than dynamic simulation time steps. When the event occurs, we're assuming it occurs instantaneously. But the other thing to keep in mind is, instantaneous is kind of relative. It's going to be, we're saying something is an event if it occurs in a much shorter time scales than maybe, if it occurs and sort of the change in state occurs at a much shorter time step relative to maybe some of the other time scales in our model. And so a good example of this is if you had a monthly water balance model where you were just calculating your water balance for each month at a time, then if you wanted to represent a 24-hour precipitation event, you could do that with an event. That would be a much more instantaneous thing than your monthly water balance calculation. Let's move on now and look at another model, and this one is actually dealing with extreme events and showing a different sort of example of hybrid simulation. So this model is just taking, basically, it's taking a model from our model library, and that's the generation of a stochastic precipitation record model, and it's just superimposing extreme events of various magnitudes on sort of the daily precipitation record randomly generated by this model. And so the daily precipitation record could be thought of as kind of your normal or typical precipitation, and then we have our sort of, our timers going to our discrete changes, going to our stock, to sort of provide the event that we're going to insert. And so all we do to insert it is we look at we look at the integrator value, and if it's greater than 0, then we insert the event. Otherwise, we just use the normal precipitation rate. And so these timers are set up randomly, but they're set up to have the average occurrence rate of, once in every 2 years, once in every 10 years, and so forth. And so when this one occurs, it triggers a discrete element, a discrete change element, which pulls out the appropriate value, representing the magnitude of that event, the 1 in every 2 year event, and pushes that into or puts that value in here. Okay, and so then that's how these events, extreme events, get superimposed on sort of our average or normal precipitation record in this model. So we'll run this model here in a second and see the evidence of those superimposed. The one thing I would mention before we move on to looking at the results of this model are that this is a manufactured model purely for sort of explanation purposes of how GoldSim works and how some of the methods in GoldSim works. We're not saying that you should generate your precipitation rate in this manner using just the monthly mean and a couple random variations, and that if you look closely at how these events were determined, you can see they're basically just scaled values of the annual depth. And so a whole bunch of assumptions are made here just to show how to superimpose these events. It's not to say this is the way you should calculate the event magnitudes or the underlying normal precipitation rate. So let's look at the model results to give us an idea, or maybe a better idea of what's going on. So I ran the model, and just to sort of show what happened there, the model goes for basically a year, basic time step of 1 day. It is a Monte Carlo model. We ran 500 realizations. And so again, if we looked at the scheduled updates, you'll see the scheduled updates are every day. But when one of these events occurs, we will have an inserted time step point. So if we look at some of the results, you can see this is the result for realization 7. And so you can see in the lighter blue line we have sort of our background precipitation, and that's with the lighter blue where it doesn't coincide with the dark blue. The dark blue just represents when there's an event, and you can see it's been superimposed in our precipitation record so that the light blue represents it, but where it coincides with the darker blue, that's where there's been an event inserted. And so you can see this one this year, and represented by this realization, happens to have 2 extreme events. Okay? And if we sort of click through these realizations, we could see that, it varies quite a bit year to year what might happen. You also notice the precipitation record varies quite a bit, and doesn't appear to maybe have as much seasonality as you might want from a precipitation record. But again, as I said, this is just a purely synthetic exercise to show inserting these events. If we look at the table, you can see when the events are inserted. And so there you can see, here's our extreme event value, and when it's inserted, it replaces what's in sort of the underlying precipitation record. And just to complete my disclaimer about sort of the hydrology of the methods shown in this model, you can see in our sort of precipitation rate, we never have any zeros. And so that's just kind of reinforcing my point that that's probably not a representation you would just want to take and use. But it does show a good way to deal with, inserting extreme events. And then we can also see, sort of our precipitation history, and this would be showing the probabilities instead. And so you can see, we are seeing some events popping up there. As you run 500 realizations, they tend to happen, multiple times. Okay, so that's our sort of extreme event models. Again, we're showing sort of superimposing extreme event precipitation on sort of an underlying average or normal precipitation record. So just to sort of summarize here on hybrid simulation, hybrid simulation sort of allows the superposition of discrete events on sort of a continuous or dynamic simulation. And so we've kind of had these little line drawings as we go on through the presentation, and so there's a new one here on the right. And you can see, if you say our red line represents sort of our dynamic simulation, you can see we've now inserted an event in there. And so we have this purplish line representing the hybrid simulation result, where we have an event, actually two events in this case, inserted in between, within one basic time step. Okay? And so in the extreme event model, we were, inserting or superimposing these extreme events on sort of an average record. And we also, in the first example of hybrid simulation, the one with the Muskingum routing method, we're kind of showing sort of an somewhat opposite or conceptually opposite approach, where we were using events to, maintain sort of a fixed time step independently of what the model's doing. So sort of two different approaches to hybrid simulation that, both can be valuable at different times with different methods. But the one thing that is important to keep in mind with hybrid simulation is, there is value to it in the sense that it provides a way to represent processes with different timescales, and even to represent those processes with different underlying timescales. And, it is having the ability to insert events at sort of arbitrary times and not just basic time steps is very valuable, especially as you want to look at different types of forcing in your models. Okay, so that kind of wraps up today's webinar in terms of the prepared content. I will remain online for another 10 minutes or so, handle any questions or comments. And also, there will be a video of the webinar posted tomorrow on our website as well as YouTube. And so thank you for coming, and I hope you have a good day. And I'll be online for a little bit to answer any questions.